Hello everyone. In this module, I'll be discussing about hot continuous extraction using Soxhlet apparatus. So in this module, I'll be discussing about definition of extraction and various extraction methods, both conventional and modern extraction method, and a detailed note on working principle of Soxhlet apparatus. Plants has been used as a medicine since ancient time for the treatment of various diseases in human beings, and the phytoconstant present in the plants is responsible for all the pharmacological effect. So these phytoconstants can be removed from the plant materials using the extraction method. The term extraction is defined as the treatment of the plant or animal tissues with the solvent, whereby the pharmacologically active constituents are dissolved in the solvent from the most of the inert materials. The solvent which is used for the extraction is termed as menstruum, and the inert insoluble material that remains after extraction is called as mark. Extraction methods include solvent extraction, distillation method, pressing, and sublimation according to the extraction principle. Among these methods, solvent extraction is the most widely used method. So, four important points has to be taken into account while choosing the extraction method. The first one is the selection of the solvent, which is very crucial for the solvent extraction method. So, usually solvents with polarity value near to the polarity of the active constituents are likely to perform better, and vice versa. So, most commonly used solvent is alcohols, which is also known as universal solvent, because most of the phytocompounds is soluble in this highly polar solvent like alcohol. The next parameter is particle size. Generally, finer the particle size is the better result the extraction achieves. The extraction efficiency will be enhanced by the small particle size due to the enhanced penetration of the solvents and diffusion of solutes. But too fine particle size, however, will cause the excessive absorption of solute in solid, and that is difficult in subsequently filtrations. The next parameter is temperature. So high temperature always increases the solubility and diffusion property of the solvent. So temperature that too high, however, may cause solvents to be lost, so leading to the extraction of undesirable impurities and the decomposition of thermolabile components. The next parameter is duration. So extraction efficiency increases with increase in extraction duration in certain time range. However, increasing time will not affect the extraction after the equilibrium of the solute is reached inside and outside the solid materials. So here, these are the four important conventional extraction method, that is maceration, percolation, Soxhlet extraction, and decoction. So the maceration is a process in which the whole coarsely powdered crude drug is placed in a stoppered container with the solvent and allowed to stand at room temperature for a period of at least 3 days with frequent agitation until the soluble matter has dissolved. Then the mixture is strained, and the solid materials known as mark is pressed, and combined liquid or clarified by filtration. And this is a very simple extraction method, and the only disadvantage in this method is long extraction time and low extraction efficiency, and it could be used for the extraction of thermolabile components. The next one is a decoction method. In this process, the crude drug is boiled in a specified volume of water for a defined time. It is then cooled and strained or filtered. And this procedure is suitable for extracting water soluble and heat stable components. Then next one is percolation. So percolation is a more efficient than maceration because it is a continuous process in which the saturated solvent is constantly being replaced by fresh solvent, and in this process the powdered drug is moistened with an appropriate amount of specified menstruum and allowed to stand for approximately 4 hours in a well closed container, after which the mass is packed and the top of the percolator is closed. An additional menstruum is added to form a shallow layer above the mass, and the mixture is allowed to macerate in the closed percolator for 24 hours. And this percolation is a continuous flow of the solvent through the bed of the crude drug materials to get the extract. And the next one is Soxhlet extraction. So it comes under the reflex extraction. So it is a more efficient than percolation or maceration and requires less extraction time and less amount of the solvent. But only disadvantage is it cannot be used for the extraction of thermolabile natural products. And the modern method of extraction includes supercritical fluid extraction, pressurized liquid extraction, microwave assisted extraction, ultrasound assisted extraction, and enzyme assisted extraction. And in this model, I'll be discussing in detail about the Soxhlet extraction. So, Soxhlet extractor is a laboratory apparatus which was invented by Franz von Soxhlet in the year 1879. And this unit has three important parts. One is a percolator through which the solvent will circulate, and thimble is a where the substance to be extracted is retained, and a siphon mechanism. So these are three important parts of the Soxhlet. And usually the Soxhlet apparatus will be assembled. First, the powdered materials which has to be extracted is placed in a muslin cloth or a filtered paper, which is placed inside the thimble, and the what we call as thimble. So this thimble is loaded into the main chamber of the Soxhlet extractor. Then the solvent which is used for extraction is placed in a round bottom flask or distillation flask. Then the distillation flask which has to be heated is placed on a heating element, that is heating mantle. Then the Soxhlet extractor is placed at the top of the flask, and a reflux condenser is placed at the top of the extractor. So this is the Soxhlet apparatus. So in this method, as I said, a heating mantle is placed, and above the heating mantle, the distillation flask or the round bottom flask is placed, which has the solvent which is used for the extraction purpose. Above the round bottom flask, we will be placing the extractor. So inside the extractor, the substance to be extracted, that is a powdered materials, is placed in the thimble inside the extractor. And the extractor will have two parts. One is a siphon tube and a side tube, and above the extractor will be placing the condenser. So these are the assemble of the Soxhlet extraction apparatus. So here the finely ground crude drug is placed in a porous bag or a thimble which is made up of a strong filter paper or muslin cloth, and it is placed inside the extraction chamber. Next, the extracted solvent is placed in the round bottom flask which is heated. On heating, the solvent will get evaporates, and the vapor of the solvent will reach us through the when it passes through the condenser, it condenses into the liquid state. Then the liquid will uh, by it will be entering into the thimble in a drop by drop, and the crude drug is get extracted by means of this solvent, and the extract will be collected to the siphon tube. When the level of the liquid in the extractor rises to the top of the siphon tube, the liquid contents siphon into the distillation flask. The thimble ensures that the rapid motion of the solvent does not transport any solid materials to the uh, still top. This cycle may be allowed to repeat many times over hours or days. This process is continuous and is carried out until a drop of the solvent from the siphon tube does not leave the residue when evaporated. After extraction, the solvent is removed by means of a rotary flash evaporator, and the yield of the extract is noted down. The non soluble portion of the extracted solid remains in the thimble, and usually it is discarded. And the advantage of this method is that large amount of drugs can be extracted with a much smaller quantity of the solvent. Thank you for your patience listening.